Hi everyone, myself Dr. Kumar. Today we are going to discuss about magnetic material and then importance. Why magnetic materials are important? You know that magnetic materials are used in variety of applications from toys to advanced research. In addition, the majority of electricity produced based on magnetic materials. Uh, you know about Faraday's law, electromagnetic inductions. If you use magnetic material, you can convert mechanical energy into electricity. So that's why the magnetic metals are very, very important. Where these properties comes from, you know that from our lowest standard we studied about if you pass a current through the conducting material, it will produce magnetic field around that conductor. In same way, in atomic scale, every material is made up of atoms. The atom it contains some charged particle like electron and then proton. If this charged particle moves, it produces current. So these things, this charged particle in atomic scale, this is responsible for magnetic property of certain material. So this individual charged particle like electron and proton, it can able to produce only certain amount of magnetic field. That quantity is called as a Bohr magneton. Its value comes around 9.27 into 10 power minus 24 ampere per meter. This is the value magnetic field produced by a single charge. Okay, you may ask certain questions. Every material it's have a charged particle like electron and proton. Then why certain material have a magnetic property, some other material don't have this kind of property? So the reason is Pauli principle. We have an idea about Pauli principle. The charged particle or electron or proton, it can be occupied in a certain energy levels. At the same time, in a single energy level, we can place two number of electrons or two number of charge carriers with the opposite spin. If that outermost orbitals, it may unpaired electrons. But inner, it should be an paired electrons. It have an equal number of electrons with opposite spins. But in outermost orbital, there may be an unpaired electron. If there is unpaired electron, it can have ability to produce magnetic field because the paired electron it will cancel one another. There is no net magnetic property in that this kind of material. So unpaired electron, that's very important. In magnetic material, there should be an unpaired electron. In non-magnetic material, there will be a paired electron will be there. So that's the reason. So these are some of the basic terms while entering into magnetic material. We have to know this kind of concept like what is magnetic dipoles. So poles means we are already familiar about it. It indicate the direction like north and south. But magnet also have a polarity in opposite polarity like north and south. If you come to different magnet with nearby, if it is in opposite polarity, it will attract. If it is in the same polarity, it will repel one another. So these things are we already discussed in from our lower standard animals. It's familiar one. Then after magnetic field. So this is a force experienced by a magnet around that particular pieces or particular material. The how much distance the force can act. The magnetic force, that's called a magnetic field. It's measured in ampere per meter. There is another kind of units also there. So likewise, flux density or magnetic induction, some other times it's called as a magnetic induction. It represents magnetic flux density. It represents if you pass through the magnetic field in a material, after a certain distance, the strength of the magnetic field will be reduced. So that's property called as a flux because its change depend on the distance. At very near to origin, there is a maximum quantity of magnetic field will be there. While going apart from the source, there will be a reduction in intensity of magnetic field. So that's called a flux. Change in strength of magnetic field, it's called a flux. And likewise, there is another two parameters like a permeability and susceptibility. Permeability, it's completely depends on the medium. How that medium allows the magnetic field to travel. That's called a permeability. And like a susceptibility, it's depend upon the magnetic material. You can convert non-magnetic material into magnetic material by applying certain quantity of magnetic field. That process called as a magnetization. In that process, how efficient you are, that's called as susceptibility. Certain material, it's enough only less amount of field to magnetize, like a soft magnetic material. In a hard magnetic material, we require huge quantity of magnetic field to magnetize, to convert into magnetic material. That's called as susceptibility. It depends upon the material. So generally, we classify magnetic material into these three categories based on that atomic magnetic moment. So the first one is a diamagnetism. It's also called as a non-magnetic material. It don't have any magnetic property. The second category is called as a paramagnetism, and otherwise it's called as a very weak magnetic material. And third one, it's a ferromagnetism. It's a strong magnetic material or permanent magnetic material. Okay. Further, we will discuss in our next session. Thank you. Thank you all. Thank you for listening.